My name is Karasik. I'm a senior machine learning engineer at Nebius AI R&D, where I lead the team of research infrastructure. And today I'm going to share some techniques that can help you turn an open source LLM into a frontier level software engineering agent. But first, let me ask you a question. Do you use any agents to write code like Claude Code or OpenAI Codex? Please raise your hand if you use them. Wow, at least half. And have you ever used open models in your production or for your hobby needs? Like Llama, Qwen? Wow, fewer amount of you, but still, let's get started. So first of all, let me share a couple of words about Nebius. Nebius is the vertical AI company. We do everything from top to bottom. First of all, Nebius is a GPU cloud, and we offer all of the latest and most powerful NVIDIA GPUs. We own more than 7 data centers around the world, with one of them is actually here in Israel, near Modi'in. You can see it on the picture. Beyond cloud, we offer inference and fine-tuning at the servers as a part of Nebius token factory, so that you don't have to bother yourself with all the infrastructure. And beyond all of that, we really believe in the value of education, and that's why we have our own learning initiative, that is Nebius Academy, where we help people become AI experts. And finally, AI is not possible without research. And that's why we are investing into research, and we have our own in-house research lab, that is Nebius AI R&D, and that is the team I'm coming from. We are committed to open and applied research. That means that we share all of our results, such as papers, code, and data. And one of our major topics of research are software engineering agents. These are agents like Claude Code, OpenAI Codex, and many others. But how does it work, actually? Basically, it is just a loop where you have a language model that generates some commands, and then these commands are executed in some container, like where you have terminal, you can open files, you can read the files, you can write Python scripts, you can run them, whatever you can do as a software engineer with a terminal, this is what LLM does for you. And so it runs in a loop where it generates some command, decides what to do next, it sees the output and reasons about the next action. And, but this is just a piece of software that we can write. But to turn this piece of software into a real research topic, we need a way to measure quality of such agents. We need a benchmark. And a benchmark like this is called SVE bench, and it is based on a really simple idea. We can ask an agent to solve some problem and then just run unit tests. And this is how we say if the agent solution was correct or not. And we have GitHub with thousands of different repositories, issues, and pull requests. And so we can use GitHub to mine real data for the benchmark. And as you can see, the competition on this benchmark is really tight. Everybody is trying to score higher. And so the question is, how do we actually make a better agent? And the answer is based on 2 components. The quality of an agent depends on the agent itself. I mean, the code you write as an engineer, all of the prompts, all of the Python scripts, and then it is a language model that powers this agent. And so you can improve any of the parts to make the agent, the quality better. There are lots of ways you can improve the agent part, the code you're writing. You can have better prompts, you can have better tools, you can write better feedback, you can do some context engineering, sub-agents. There are lots and lots of stuff you can do here. And this is a perfect place to start. And this is what you should pay attention to if you're just starting and you don't have a large amount of scale. You should just rather rely on existing language models. But at some point, especially if you're quite large, you also want to improve the model. And there are many ways to improve the model. The first way is to just sit and wait for OpenAI to drop the next best model in the world. It will work, but there are two problems. First, there is nothing we can do to make OpenAI release the next best model tomorrow. Second, these models are quite expensive, especially if you're a big one and you spend quite a lot. So an alternative here is to focus on your specific use case, on your problem that you want to solve, and improve the quality based on this observation. And now I'm going to share some techniques here. The first technique is called best of n selection, and it is a very simple and intuitive technique. So we know that language models are random models. And if you run the same model with the same prompt several times, it will produce different results. And some of them will be better than others. And so if we had a chance to automatically select the best result, this means that we are able to improve the quality. And this approach can work with any model, with open model, with closed model, with fine-tuned model, it doesn't matter. The main idea here is we can run the model several times and select the best result. So how do we select the best result? And the answer here is called critic models. What are the critic models? Critic models are also a really simple idea. It is just another model that we use to select the best completion. There are many ways to implement such models. One of them is when we have our set of completions, we want a model to assign a score to every completion, some number, and then we just sort all of them and pick the first one with the highest score. And for instance, we can do this just by prompting another language model to say, hey, this is my completion, here's my evaluation criterions, please assign a score from 1 to 10. And there are other approaches as well. And the great feature of this approach is that it can be applied on different levels of the agent. You can use this technique inside the loop when you are actually trying to generate completions from a language model and select the best action, like the best command to execute in a bash terminal. Or you can also run the whole agent end-to-end several times. It will produce several results, and also some of them will be better than others. In the case of software engineering agents, it means that we will have several pull requests, and some of them will be better. And so we can combine this technique on both levels. We can select the best action, and we can also select the best result. And as we show with our research in our paper, that this technique is extremely powerful. For instance, we had GPT-4o as a base model for our agent, and initially it scored just 22%. But once we combined both of these techniques, we were able to increase the quality up to 40%, which is almost a 2 times increase in quality without any fine-tuning, without any modifications to the model, just by running the model several times and selecting the best result. And beyond best of n selection, the next technique is, of course, fine-tuning. Fine-tuning is once again an idea that you don't need a really super intelligent, super generic model. You have your problem that you want to solve, and you want to get a best-in-class model for your specific problem. And fine-tuning is a way to get a model tailored for your use case. And this model can be smaller. This model can be cheaper to run at scale. And also you can deploy this model securely in your own environment without any dependence on any external provider. Or even it can be an on-device model, as it was shared in the previous talk. So there are many ways to fine-tune a model. The first one I'm talking about is supervised fine-tuning. And supervised fine-tuning is just when we have some set of good examples, and we want the model to remember those good examples, and we want it to behave as we showed previously. So the previous step before supervised fine-tuning is just a multi-shot learning. When you have a couple of examples and you put them into your prompt, but as you have lots and lots of examples, putting all of them into a prompt is not viable technique. And so you switch to supervised fine-tuning. And beyond supervised fine-tuning, another family of techniques is called reinforcement fine-tuning, which is based on reinforcement learning. And the difference here is that reinforcement learning can learn from both good examples and bad examples, from all kinds of experience you can have. From everything that happens in production, you can learn from both kinds of experience. And there are many algorithms that implement this reinforcement learning idea, such as DPO, that learn from pairs of good and bad, and there is also GRPO that learn from groups of examples. And the latest models that do reasoning or thinking, if you call it this way, actually were trained using this GRPO. And as we also show with our research, fine-tuning is super powerful. For instance, we had Qwen 2.5 72 billion model, which initially was quite a poor model, just around 10% quality. But then we applied supervised fine-tuning and we got 20% quality, which is 2 times increase. And on top of that, we then applied reinforcement fine-tuning, which brought us another 2 times increase in quality. So we started with 10 and ended up around 40, which is 4 times in total. And what is really crucial here is that we have a model which is quite small, but it performs just as good as a huge DeepSeek V3 model, which is 10 times larger. Our model is much smaller, much cheaper to run, and still it is as good as a huge model. So, if you want to run inference and fine-tuning of open models, we have Nebius Token Factory here for you, where you can do this in minutes without any infrastructure burden. And on a side note, as I mentioned earlier, we have a data center here in Israel. And actually, we are given a unique chance to visit our data center and see all of these GPUs, super expensive, super powerful hardware in real life, if you come to our booth of Nebius and talk to our representatives. And finally, AI is nothing unless we know how to use it, and unless we know how to create it. And that's why Nebius Academy helps you become an AI expert. And we have a course on AI performance engineering, where we actually teach how to train and inference all of this model under the hood at scale. So, and you may even have me as your tutor on this course. So scan the QR code to learn more. So that's all from my side.